Hi, everyone. Welcome to this Platform 9 webinar on modernizing your infrastructure. We will get started in just a couple of minutes. I know everyone's sort of either getting settled into lunchtime if you're on the East Coast or just getting a day started here on the West Coast of the US. So in just a minute or two, we will kick off. Welcome, everyone that's just joined in. We'll kick off in just another minute, just giving everyone time to get started. All right, I think it's about time to jump in. Thank you, everyone, for joining today. With me is Janakaram, who's dialing in over Zoom, and industry expert analyst on containerization, cloud native, and our modernization discussion here as well. Janakaram, do you want to introduce yourself?
Sure, Chris. Hi, everyone. My name is Janikiram Jani, based out of Hyderabad, India. Been in the industry for about 20 plus years, ex-Microsoft, ex-AWS, and currently an advisor to startups. Looking forward to having a conversation with Ron today on infrastructure modernization.
Excellent. And with me in the Platform 9 office today is Ron Haberman, our market CTO and ex-CTO of Nokia, and I'll let him introduce himself.
Thank you. Very happy to be here. Spent quite a lot of time on infrastructure and let's call them enablement services. I was a CTO of Nokia Software for many years and helped lead the transition from hardware to software and then to cloud and SaaS. Then did some cloud gaming and things of that sort. And now part of Platform 9, looking to see how we can help the broader market make that transition to cloud native.
Excellent. Excellent. Before we jump into the content, I'm just going to throw out a poll for the audience. This is around budgets for 2023 and whether or not you're seeing any change. So I'm just going to launch this poll. You're about to see it in the Zoom controls. We'll leave it open for a minute or two and I guess get started into our conversation. Ron, Johnny, do you want to kick off?
Yeah, absolutely. So are you going to bring up the poll or should we just get started with the conversation?
We'll leave it open for another moment or two and see the responses we get.
Okay, cool. So, Ron, we are going to discuss quite a few things today, but obviously in the last couple of years, there has been a lot of emphasis on app modernization. Basically the move from legacy workloads to containers, microservices, and creating modular, composable architectures. But what I'm seeing in the market and what I'm seeing in the industry, particularly with large enterprises, is the whole point of infrastructure modernization versus application modernization. While there is a lot of emphasis, a lot of focus, and a lot of discussions and investments around app modernization, infrastructure modernization, what I personally feel is the fundamental transformation that an enterprise has to start with. So I'm just curious, what do you think of modernizing applications versus modernizing infrastructure? How should an enterprise structure this, and what comes in first, what comes in later, and how to prioritize this whole investment of modernization, whether it's apps or infrastructure?
So I think interestingly enough, we usually jump into the discussion of technically how to achieve modernization, but I want to take a small step back to ask the maybe obvious question of like, why should we modernize at all? At the end of the day, in most healthy organizations, there would be a business view as to why do we need to change from our current mode of operation? And in most cases, it's going to fall into very few categories, right? Either you would like to go to market faster, or you're trying to create new services not possible with the current model. You're trying to save money, okay, on licensing, on operations, on recovery from outages, or you're trying to make the experience for your customers better, okay? And when you look at those and try to translate them into which application or infrastructure you should do first, the answer is yes. You need to do both of them. Yeah. The reason why, in my opinion, why we go back and forth is because each have their own challenges, and in order to accommodate those, business goals, you might find yourself finding an easier first step in an application. And we should talk a little bit about kind of like the presence and impact of what public cloud brings, in a few minutes as well, because I think that created, a perspective. So when, at least in my history, right, when we looked at modernizing the application, it was seen as the absolute first thing to do in order to achieve some of the very rudimentary expectations from being a modern technology organization. And the first one was that you're trying to create some form of infrastructure independence. Yeah? So if you're going to build your software in a way that allows you to switch infrastructure and move between technologies, in most cases, especially when you might still be in some form of a legacy mode, would require you to touch the actual application as a first step. On the other hand, the absolute second piece would be that the operations of those applications on infrastructure, and my favorite topic is always to talk about dynamic scaling, require that the infrastructure itself would be modernized as well, right? I mean, before you go to an application guy or girl and tell them you need to change your code to be able to be more dynamic, you better have the capabilities to accommodate such requests at the frequency that we would like those applications to run, right? And if in the past a change to consumption would happen literally after a meeting, yeah, so very rarely, now the expectation is that it should happen many times every day in order to optimize the utilization of your infrastructure. So depending on the workload and the workload age, I would argue that you can start from an application if it's brand new or close to being new, or you should actually start from infrastructure if you're talking about maybe a little bit more of a legacy type of workload, or just a workload. The term legacy, I'm reconsidering just because it might have a negative view. It doesn't have to be old or out of date or anything like that. It just needs to be already in operation. So if it's in operations and it's doing what it's supposed to do, and you don't want to make the huge investment in putting developers into dealing with it and only seeing results in years from now, then you should start from the infrastructure and see what that will do to create the business benefits. Sorry for the long answer, but
no, I completely agree. But for the audiences and for the customers, there is a clear path when it comes to app modernization. They visualize this from moving to containers and microservices. So when you break a monolithic application into modules and components and composable entities, they actually call that as making the application more modern and targeting things like containers and serverless. But when it comes to infrastructure modernization, how do you define that path? Is it moving from physical to virtual, or virtual to public cloud, or virtual to containers? What is the definition of modern infrastructure?
So I think that the industry over the past 10 years now have defined those in stages. Yeah, if you think back of when an application was married literally to a piece of hardware, sometimes even proprietary hardware. Obviously, the first and absolute first step is to virtualize it, right? Just to be able to create more utility of the hardware and obviously replace the hardware underneath it. But as you go through, what we define as generations, you see more and more detachment, not just between the application and the physical infrastructure, but also when you go to microservices, between the makeup of the application itself. So the relationship between all those microservices. And as you start to run the application in truly microservices, you start considering whether you should actually build pieces of the application that maybe in the past were mandated to be part of the application, and start consuming things that are applications by themselves as services. Okay. Now back to my favorite topic. I completely agree with the view that for the application to be modernized, it needs to be placed into containers and re-architected to microservices and get detached from the data to some degree and make it stateless, et cetera, et cetera. The fear that I have with just defining those capabilities is that what happens more often than not, especially with applications that have been in production for some time, is that you go to the trouble of doing all these things, and then you reassemble them all back together into the monolith. It's just that now the monolith is built from a bunch of microservices that are always on, connecting to data that is always available. Okay. So the goal is not to go simply to a new architecture, but to change the way you operate that new architecture. And the goal, at least in my view, is actually to take the benefits for which we redefine. So infrastructure independence, utility of the infrastructure based on consumption, the ability to launch and remove services that are required and remove them when they're not required, be able to simplify the data path between all those different elements, et cetera, et cetera. And when you do all those things, right, it actually drives the operational model from the infrastructure. We drive the operational excellence and the need to modernize infrastructure itself. Now, if again, we take a quick step back and try to think of like why, at least up until this year, right? I mean, public cloud had been kind of like the golden child. This year, it a little bit fell out of favor, but for many, many years, it was the target. Yeah? And it was the target in part because it defined that future mode of operation of how infrastructure should be consumed. Yeah. And the reason, at least in part, of why now it's falling a little bit out of favor is because there is this realization that just because infrastructure is capable of a certain mode of operation doesn't mean that you take advantage of it. And many organizations found themselves with doing a lot of work, okay, moving both in engineering and in how they re-architected the software, only to run in exactly the same way it ran before, not taking any advantage in pricing, in capacity, in pushing more code to production faster, than before because they haven't bothered changing the basic processes of how to consume the infrastructure. So we have to kind of like consider these two things together.
Got it. So basically, it is the combination of both. On one side, you got to modernize your applications to take advantage of the elastic dynamic infrastructure, and at the same time, you should also make the foundational aspect of your infrastructure elastic, dynamic, and move to the latest paradigm, which will give you the best of both. Basically, the combination of applications and infrastructure, which work in tandem to deliver those attributes of, going to market faster and resiliency, availability, and all of those. So, well, there has been.
I would add just the third leg, which is that your operations and processes have to evolve in parallel. Yeah, I mean, you need to require, okay, in a way, and when we talk to CTOs and CIOs these days, they understand that the processes, the way operations is expecting the behavior needs to be set as a goal as well in order to drive those two tracks.
Right. So while there are candidates that are ideal to modernize, what do you think are the workloads that will continue to be the way they are and become the backend or the digital backbone of these modern applications? What are those workloads that can never be touched? They are too big to fail, too hard to modernize, but they are playing a critical role in the overall success of an enterprise IT. So what are those workloads that cannot be modernized and continue to be where they are?
So let's take maybe two examples. Okay, one I think is simple and something that I think most big IT organizations will identify with, which is that they have a vendor supplying them with an application. The more heavy user of data, not to mention a database that needs to be on premise and managed, would be a good example, where they have a core dependency of the organization on that piece of software. And that software has, a lifespan. Yeah. So that application comes from a vendor that has a roadmap, which may or may not include, containerizing it. And it's absolutely mandatory for the way the business works, okay, at that point in time. And specifically, which one it would be obviously will differ depending on, depending on the organization. But every big organization will have, such an example. In my history, it was, chip design software. Okay, I mean, it was there forever, right? It does what it's supposed to do. There's a dependency pretty much of all dev organizations on that piece of software. And to be frank, I mean, features of that piece of software is more important, okay, than how it works, because it needs to pretty much work at capacity all the time. ERPs, a few other examples comes to mind. The other, which is a little bit more tricky, is in an organization that had built their own software, okay, whether they're selling it for use on-prem by others, or maybe even more modernly providing them as SaaS. Okay? And there's always going to be this debate on the investment that would be required to modernize that piece of software. And the answer might not be trivial, that sure, we should go to the next best thing. Why? Easiest way is that it was created in a language that doesn't lend itself very well to this type of transformation. So you effectively will need to have to rewrite the whole thing. The other is that you can start modifying it, but to gain the full benefit will be a multi-year process. Okay, so you need to make a substantial investment in your own, engineering before you can start reaping the rewards of being in this new architecture. If you're closer to being able to offer it as SaaS, obviously that would happen faster. If you're not, it's probably going to be many, many years before you'll see the benefit, simply because you need to then change the mode of operation of your own customer, okay, in order to take advantage. So unfortunately, I don't have a formula. Yeah, the decision is, business case dependent, and the simplest case of things that do not lend themselves well to be rewritten are things that are just acquired by the business, required by the business for their operations, and it will have their own roadmap of change, if any.
Got it. So the takeaways from this is things like transactional databases that have petabytes of data that cannot be moved to the cloud, or cannot be broken down into microservices because it's a piece of software that has been there for a long time. And similarly, data warehouses and the data-driven backends that are extremely large. And of course, you mentioned ERP and some opaque homegrown applications or third-party line of business applications that cannot be easily decomposed or cannot be made modular. So those are the applications or backends that are going to be where they are. They cannot be really migrated over to modern infrastructure or to the cloud. So in that case, we got to bring applications to data instead of moving data to applications. So what do you think are the ideal candidates for modernization and applications that can take advantage of these big backend databases, data warehouses, and data-driven applications that are powering the enterprise IT? So what is the sweet spot for app modernization? Where do customers typically start?
Yeah, very different per industry. But if you think of things that are mobile app driven these days, they tend to be very transactional in nature. Yeah, the user goes into a particular area, they ask for an outcome and expect to get the outcome quickly, and then they can go quiet for quite a long time. If you go and translate that to what is seen in the back end, it's easy to understand that the thing that they ask, whether it's to determine location, path, do a financial transaction, order goods, interact with a branch when they order their coffee, understand a particular, review. I'm just trying to come up with these things that we all do every day. It's a very short-lived piece of code that needs to be invoked. Data will arrive to it from a source. It will do its compute, send a result, and then it can, go dormant again. And if your business has this type of transactions that need to happen kind of like independent of one another, and of course, the more time-based that they might be, meaning that peaks would be much higher than the lows, the more likely it would make sense for you to go and build them in a cloud-native fashion. And not to go too wide, but any new business that is building software in the past 5 years, okay, I would say even more than that these days, is likely to be in that bucket by default. Yeah. So for example, I mean, when we go and look at, what it would look like to take, to build, even our own code, yeah, and say, how are we going to serve our customers better to the point where at 8 in the morning, okay, when they go and review their infrastructure and try to understand what they need to do for the day, they will consume a lot more resources hopefully, okay, we expect than what it would be at 2 in the morning when there's a lot less interaction with systems. It would be a very, very good candidate.
Got it. So what are the concrete examples? Is it going to be like a public facing website or a mobile backend, or what are the typical, what is the low hanging fruit for an enterprise IT application to be modernized?
So yeah, you mentioned too that obviously are applicable, like mobile apps both the front end and the back end, websites, any kind of customer engagement, any kind of transactional on data that is required now, take an interface into a banking system, for example. But I think that if you actually go back and look at these requirements from the perspective of a particular vertical, take a warehouse piece of application, okay? The warehouse needs to do inventory. Yeah, the inventory happens on a regular basis, and whether the inventory mechanism itself is automated or not, which we'll talk about in a second, it is transactional in nature. So while most businesses and most consumers will not understand how an inventory process works in a warehouse, it would make a very good candidate. Now, the reason I bring the automation into play is because that also is a very good candidate to run in a cloud-native fashion. For example, now we're working with customers that use drones and vision in order to do the inventory itself, even before it goes into the backend system to get merged with that particular enterprise view. If you look at what we do with the coffee shop, then the front end, okay, of the app obviously is very transactional, but how they actually manage the branch, meaning the shop, is a very good candidate of becoming cloud native, because it would make the use of the system, very efficient. And then from my past and now working with, partners in the telco area, you as a consumer connect your phone to a network, okay? When you move data, when you connect to any kind of website, when you utilize your 4G, 5G connection, obviously you use a piece of software that translate your phone signals into packets, okay? Not to get too technical. You don't do that usually or at the same capacity at 2 in the morning, yeah? Which means that piece of software that runs there doesn't need to consume as many resources as it would when it's 7:30 in the morning and everybody is using their mobile phones or tablets, etc., to check the news and get updates and email and understand what they're going to do every day. So for an average listener, I expect that they would have no understanding of that particular enterprise use case, yeah? And yet it is a prime candidate of something that would greatly benefit from the characteristics of being cloud native.
Got it. So when we analyze the landscape, essentially there are going to be 3 classes of workloads. One is running inside containers. The other one is running inside virtual machines. And then there are certain managed services offered by public cloud providers like managed databases and managed data warehouses and so on. So predominantly, these are the 3 segments that an enterprise would run their workloads into, right? So those are the 3 things. Now, obviously, Kubernetes has become the de facto for orchestrating containers. And today we have a variety of distributions, including Platform 9's own managed Kubernetes and multiple other open source and commercial distributions. But customers typically deal with heterogeneous orchestration managers, one for virtual machines, one for cloud provided by cloud providers, and then Kubernetes either running on-prem or in the cloud. So do you see the convergence and the de facto orchestration engine managing all these three silos? One is the VMs, the other one is containers, and the third one is the cloud-based managed services. Do you see Kubernetes evolving to become that remote control or the magic wand that can handle all these three environments?
In one word, yes. And in a few more words, but I think, like every technology transition, it goes through phases, and there was a time, okay, very recently, that Kubernetes took over as a next generation orchestrator, okay, for dealing with infrastructure. So much so that it was seen as everything will just become containers, and we really don't have to worry about these other two types of workloads that you mentioned, especially VMs. And we have a tendency, especially in the IT industry, to do that, right? I mean, here's the new thing, so clearly it's so much better than the older thing, that everything will shift. And now we're in this phase of a little bit of realism coming back in. And actually, I had a conversation with a colleague a few days ago who reminded me that there's still quite a lot of organizations using mainframe. And yes, mainframes will stay with us for quite a while. If you're gonna, rewrite, your banking mainframe application, I would highly recommend you would just go to containers. But it's all to say that VMs are not going anywhere in the near future. And the best thing that we can do as infrastructure providers, and in a nutshell, right, a company that cares mostly about optimizing how infrastructure is managed, is to bring these things together to at least gain the benefit of not requiring three different types of individuals knowing how to deal with these disparate platforms.
Right. So we are almost 70% into this session. We covered a variety of topics, and I want to just quickly recap before we go further. So we started with the importance of infrastructure modernization in the same context as app modernization. Then we talked about the ideal workloads and not so ideal workloads that cannot be moved to the modern infrastructure. And we are now discussing about the ability to orchestrate environments that are running within VMs, within containers, and cloud-based managed services, and Kubernetes becoming the de facto for any of these workloads. So do you actually see Kubernetes taking over the orchestration of both VMs and containers? There are some open source projects that are actually capable of doing it, but how viable it is, how reliable it is to make Kubernetes control your virtual machines alongside containers. And from a technology perspective, what do you see that as an enabler of modern infrastructure and also the modern applications?
Yeah, so I think that most of the people in the audience and yourself obviously is very familiar with KVM. Okay.
Right.
Now, KVM, provided the facilities to run VMs coming from the open source environment for many, many years. And it's also the basis on top of which containers run, and Kubernetes as an orchestrator have been enabled. Now, what the progress that the market had made, starting from upstream down to providers like ourselves, is the use of a project called KubeVirt. And KubeVirt, in a nutshell, is an add-on to Kubernetes that allows the operator to take advantage of the APIs, automation, intent-based scheduling, et cetera, in order to bring VMs into a container world. And in effect, okay, the VM then run effectively as a pod, orchestrated by the same mechanism with similar APIs, and depending on the system, either with a CLI or with the UI. So the answer to your question is yes, and the facility, okay, to achieve that is available. We started integrating it into our product about a year ago, and as the capabilities getting ever enhanced, like starting and stopping and live migrating, creating redundancies, etc. in the VMs, I think the intent and the type of engagements that we see is starting to morph. Okay, and if in the past, a year, 2 years ago, it was seen as a stepping stone, okay, to containers, and I was involved in many conversations where the focus was, okay, we're going to bring a VM in as a temporary thing, okay, until we complete the change and rewriting the application, et cetera, et cetera. Where now we discuss, and engage with customers that has literally, okay, tens of thousands of VMs. And everybody is fully aware that some of them, a big part of them, will never make that other step, okay? They would need to run as VMs with their workloads for infinity in terms of IT, okay? Meaning 5 to 10 years. So it really changed kind of like the relationship that the organization then needs to consider between the world of VMs and the world of containers. And that touch point then becomes Kubernetes. And the conversation then really goes towards the, how do I make sure that my next generation platform combines these worlds? So I don't have to have hardware separately, which makes movement of workloads really, really difficult, right? You're going to be inefficient on both at all times. Skills of people, like, do I hire more people that know how to deal with platform A or platform B? Okay, do I prepare the future, or do I back up the past? And then the workloads themselves. I mean, do I have to be in a hurry to go and take one of these applications and move them over, or can I actually gain operational efficiency by running that VM in the construct of the new world, okay, for lack of a better term?
Got it. So essentially, from a technology point of view, from Kubernetes perspective, it is going to be as seamless as doing kubectl get pods. Now I can actually do kubectl get VMs, and these VMs will run stateful legacy workloads, while pods will continue to run stateless modern applications, and both of them are first-class citizens from the Kubernetes point of view, right? So this brings in a lot of advantages of unifying the API, unifying the automation tools, the skill set, the learning curve, and converging the infrastructure of containers and virtualization into a single plane, which is very promising. And I want to just sidetrack this discussion a little bit and tell the attendees that a week from now, on 16th, we have a deep dive on KubeVirt. So if you are coming from a technology background and you want to understand the custom resources and how virtualization is handled by Kubernetes and how pods and VMs can coexist, stay tuned for that. We are going to share more details about this session towards the end, but we do have a technical deep dive coming up next week. So now coming back, what is the takeaway and what do you think is the roadmap to modernization, both the path of infrastructure and the path of applications? So is there like a blueprint? For example, most of the public cloud providers have a blueprint and a roadmap and a well-defined migration path to the cloud. Do you see something similar for customers to basically use a blueprint for modernization on the infrastructure track and the applications track?
Yeah, I think that for platform 9, yeah, the answer is a little bit more refined, okay, than one blueprint. And the reason is that because we can run on-premise and in VMs or in public cloud and consume public cloud services, all part of one UI, there is no hurry, okay, on our part to go and say, this is the answer, right? When it comes down to is a fairly deliberate process of understanding what are the existing workloads that the organization has, what are the workloads that are in flight or planned to be built, and where those workloads are on their path to becoming cloud native, okay? And there would be kind of like three big buckets. Yeah? Those that will never be cloud native, those that the organization just wants to kill, okay, and replace with something else, or things that are becoming cloud native, or already obviously are cloud native. What we will do then, we will size the infrastructure for these workloads, and the ability to bring VMs and run them alongside of the containers basically mean that the infrastructure sizing exercise will be fairly simple, right? We have one system to design. It will have one platform installed. And as these workloads are morphing, okay, from being in a VM to being fully containerized, the process of moving them out, right, and killing the old is going to be fairly seamless and very efficient in terms of resources. All the legacy apps will be identified, okay? Those will take fairly permanent resources, and, you know, you'll have a timeline of how to bring them in from wherever they run. I mean, they run obviously in some form of a legacy platform, and migrating them from that platform into platform 9 will become the meaningful exercise. And that's usually where, you know, I think public cloud companies have issues just because it's so outside of the comfort zone of something that was designed for that particular cloud platform, that they're running into difficulties. And maybe the easiest example, you know, we talk a lot about, you know, Kubernetes and KubeVirt and things of that sort. But when you start bringing VMs, those VMs bring guest OSs that, you know, may or may not be recent. Yeah. And if I have an application that has been in use and running in, you know, Windows 2000 Server 2008, yeah, it would be great, okay, if it can just continue to run this way. And this is something that we will work very closely with our customer to bring into the system. Then we will review the application requirements and see, you know, what specifics, okay, for example, packet acceleration, networking, you know, the use of GPU and the need for GPU pass-through that they might need on either side of the platform. And maybe most importantly will then be, how do you then run this combination in scale of number of servers, number of locations, number of clusters, scaling the number of operations, so what type of roles they have and who is supposed to deal with what type of the platform in the different areas. And all these things, right, will be taken into account as we're building the design together with the customer. And depending on these workloads, I mean, they might want some of the workloads, or they actually might have a mandate for some of the workloads to be on premise because of regulatory reasons, because of data protection reasons, because of their CISO paranoia, whatever it might be, okay? They want to run some things purely on-prem. Then some of the workloads can run on server for hire, right? So they don't see the need because of a financial reason or because of a proximity requirement to go all the way to public cloud. They want them in original server for hire. And then some workloads or some services that consumed from public cloud. And all those different environments, VMs, containers, location, bare metal, running inside VMs, edge, central, public or private data centers, are all aggregated into essentially a single UI. And that single UI is also powered by a very rich API. And what it gives the new platform team is essentially kind of like a one-way to do what they need, okay, in order to optimize the management of the platforms themselves, providing a much better service to their businesses, and B, giving interface to their developers to have more freedom to do what they need to do, but within guardrails, right? In a way that will not violate, their spend target or the use of unapproved services or locations, not to mention breaking regulatory requirements of keeping the data safe. So that would be the process more so than the blueprint, okay, that we will talk to customers about.
Absolutely. So I completely agree that it is not as straightforward as defining a roadmap, identifying the milestones, and going through a checklist and ticking off every box in that. It is much more complex and much more long wound than what it seems to be. So to summarize, we're almost at the end of this session. So to summarize, basically, if you haven't migrated to virtualization or VMs, you still have bare metal servers, I think it's time for you to look at virtualization as an important enabler to basically move those workloads into VMs and bring them into the fold of Kubernetes, bring the modern applications as containers and microservices, and manage it through Kubernetes. So Kubernetes becomes the front and center of your orchestration while managing virtual machines running legacy workloads that cannot be broken down into microservices, and also a set of modern applications that are already modular, already packaged and deployed as microservices. And of course, the extension of some of these services to the cloud. You can do that through things like Crossplane, which is giving you the API to manage. So you bring all of them under one fold, which is Kubernetes, and you can get the advantages of automation, DevOps, and CI/CD, and apply the set of best practices that you have been applying for Kubernetes-related workloads, but to the entire spectrum of applications, whether it's VMs or containers or cloud services. So excellent. So that brings us almost to the end. Chris, can you move to the next slide where we can announce the upcoming deep dive on KubeVirt? So on March 16th, I'm going to joined by Anmol Sachin, an engineer from Platform 9, and we're going to do a technical deep dive on KubeVirt. If you have questions about KubeVirt, on how it integrates with Kubernetes and what is possible, what is not possible, what can you really accomplish with KubeVirt's integration, stay tuned for this. This is going to be a very interesting technical deep dive on managing virtual machines alongside pods and containers. So that's on March 16th. At 10 a.m. ET and 7 a.m. PT. You can sign up with the link that we are going to share very soon. So that brings us towards the end. We don't have enough time for questions, but in case you have questions, maybe you can type in the chat box of the Zoom application, and we'll try to answer them.
Cool. We also have one more poll that I'm going to throw up there. Well, that's going up. Talk about the results of the first poll. The overwhelming majority of respondents said they were seeing their budgets cut, which is interesting. When I look at market research by the likes of Gartner and others that are out there, they've sort of been saying that CFOs are holding budgets steady and maybe reprioritizing or refocusing where those are. Johnny, what have you been seeing?
Sorry, could you quickly rephrase? I lost you for a few seconds.
In terms of the organizations and people that you're speaking to in the market, are they increasing spend? Are they decreasing spend, or are they refocusing what they've got allocated?
Yeah, so given the economic conditions, obviously there is a cut back on a variety of initiatives, including modernization. So the budgets are definitely shrunk. They are not the same as it was last year. That is the global trend that I'm reading, seeing, and hearing about everywhere. So customers are basically looking at doing more with less, and cutting down on various measures, to control the cost.
Yeah, and needless to say that we've identified that quite some time ago, and the system is designed to be much more cost efficient compared to some legacy systems. And then, as we discussed today, this combination of operations and really the utility of the next generation platform would help the platform team essentially be able to do more than less. The last thing that most organizations would want to hear is that because there was a budget cut, you can do less, right? Bring new nodes in, create more clusters, be able to bring new workloads. All these things are expected to continue to increase while the budgets decrease. The way to deal with that is to get into a modern system that relies more on automation and gives you the power to achieve more with less.
Right.
I'd
Absolutely.
agree. Cool. The results are in for our second poll. So we'd asked, are you currently running Kubernetes in production along with VMs? So I guess the KubeVirt question. I guess I would say the 50% of respondents, because it is exactly 50%, said not yet, but they're trying to figure out if that's something that they can do. I think it would be good to sort of touch on those benefits again of getting that converged environment, right? Instead of having, virtualization one platform or maybe bare metal another platform. What really is that benefit you're going to see by bringing the two together? Johnny? Ron?
So the main benefit would be, I guess there were two main benefits. One, and sorry for being a broken record, the operational capabilities. Yeah, I mean, usually these platforms are very different. Okay, the legacy VM platforms look and feel and do things very, very differently from Kubernetes. So you end up maintaining that skill set while creating a new skill set, and essentially all the processes in your business differ. The first benefit that you'll get is that your organization will get trained on the future mode of operation and make that applicable to your existing VMs. The second, from hardware utilization, from a connection with cloud resources, you will see a huge benefit as well, because you will bring all the workloads into one set of infrastructure that you can optimize as you make these changes. And I guess I missed the question specifics, but the question was specifically, do you run them together? Right?
Together, yeah.
Together, yeah. Because I expect that a lot more than 50% run both already. It's just that I would guess that if somebody started, let's say 3 years ago, it was much, much easier for them to not consider everything, but just create like a little cluster on the side for the experimentation with Kubernetes. And with time and with effectively the takeover that is happening with Kubernetes, now they're finding themselves in the situation of like, oh, wait a minute, we doubled everything, right? So maybe it's time to to consider bringing those things together. And I would add that the realization, and that's what I'm just hearing from the market, of customers saying, we understand now that these set of VMs are not going to go anywhere, lead people to say, okay, maybe it's time to find savings in operations, in licensing, in how we do things in that VM landscape as well, and not just focus everything in just containers. Right?
Yep.
And KubeVirt and what we do around running VMs in containers, I think, is a very, very easy thing to understand when people see how the two come together. So definitely join the next webinar, because I think seeing how it operates will clarify quite a lot.
I'm also sure there's people out there thinking, will Windows work? I've got all these Windows workloads. Can I put them in a VM and
Yeah, in the guest. Yeah.
in the guest? Yeah, the guest VM, not Windows containers,
Yeah.
but the guest OS within the VM within KubeVirt within Kubernetes.
That's right.
So it'd be good to see that live. It's a great working example.
That's right. And again, I mean, I know that most people probably understand it, right? But I mean, VMs with Windows guest have been working on KVM virtualization for a long time.
For a very long time.
This new enhancement is not reinventing, okay, like a hypervisor. Yeah. So a lot of these capabilities come in. The new is in how you operate it, being intent-based and single control plane, effectively being Kubernetes.
And I personally have been watching KubeVirt for at least the last 3.5 years. One of the things that I think it brings to organizations that they might have been waiting for is self-service.
Yeah.
I think it's much easier to build a Kubernetes cluster and say to an engineer or developer, here you have access, right? Because it's got really strong and granular access controls.
That's right.
Well, if you add virtualization in there, that all just translates. So now you can start handing out self-service VMs with quota management in a much more eloquent way than you could have with the last generation of virtualization platforms that sort of predominate in the market.
Yeah. But while keeping, I guess the predictability of IT, that there is this perception in the world that, when IT wants to run faster and give, their developers more capabilities, they lose control, they lose predictability, they lose things like, the ability to make sure that everything is secure, that resource utilization and cost controls are in place. Well, this development brings they maintain the control while giving the capabilities, which
Correct.
I know for many platform teams is very, very important. I mean, we've seen customers coming to us now essentially saying that cloud is a multiple, okay, of what it was supposed to be.
Or they have multiple clouds.
And they have multiple clouds, true.
Cool. Johnny, anything you'd like to add as we wrap up?
No, Ron covered it pretty well, so there is nothing much to add there.
Excellent. I did not see any questions that came through from the audience. So with that, I think we'll say thank you all for your time. Great conversation, and do join us next week for a deep dive into KubeVirt. I think it's going to be a really exciting session.
Thank you, everybody. It was a pleasure being here.
Thanks, Ron.
Thank you.
Thanks, Johnny. Have a great day, everyone.
Bye.